Good morning, guys. So here we are in the middle of almost at the end of Spark and Scala workshop. So let me share my screen on WebEx, and then we'll start with today's session. And there are a couple of folks who doesn't have names. So please add names if you want to chat later. That way I will not have confusion who is speaking or who is asking the questions in the chat. Okay, so I'm starting screen sharing, and I'm actually starting recording in WebEx. Okay, so now the recording is started. So far what we have covered core Spark, and we have covered uh, accumulators as well as broadcast variables. They are also treated as core Spark only. But let us revisit what all are covered so far, and whether they are in line with the certifications which we are planned to give. So before start, let me mute everyone because I'm hearing some background noise. Okay, now it should be fine. And also let me actually make sure that YouTube session doesn't have any issues. Yeah, it looks good. Now let us start. So I'm again reviewing the certifications. CCS 175, whatever we have covered as part of this Spark, Scala and Spark workshop, the relevant content is only core APIs. So it's all about reading data from HDFS, writing data back to HDFS, and then joining disparate datasets together using Spark, which we have done. We have joined orders and order items. Calculate aggregate statistics using Spark. Filter data into smaller dataset using Spark. So you should know how to filter the data using equals or dot equals function. And then write a query that produces ranked or sorted data using Spark. All these things are covered. Okay, if you have any questions in this, let me know at any point in time. Well, it could be part of today's session, or you can ask the questions offline also. Okay, so let me move this little bit side. And then another certification which is relevant when it comes to Spark is HDP CD Spark. And here I am opening the official page of the certification, and click on View Exam Objectives. And we have covered almost all these things, including broadcast variables and accumulators. So understanding broadcast variables and accumulators is important for HDP CD Spark. Okay. Now, when it comes to HDP CD Spark, there is another category called Spark SQL. And as part of Spark SQL, you need to understand how to create data frames from an existing RDD, perform operations on a data frame, write a Spark SQL application, use high with ORC from Spark SQL, and then write a Spark SQL application that reads and writes data from Hive tables. So all these things has to be answered. Means you should be familiar with these things also. Okay, so let's start with Spark data frames. So let me go to my website because I already have some content for reference. So this is the lesson, but it is not completely done yet. I stopped in the middle. I got busy with other things, and I stopped in the middle. Okay, so this is the link. I don't know who is that person pinged me privately. He's saying I'm not able to see the screen. Probably you might have to log out and log in. Okay, Sorry, this is not the link. Let me give the link. This is the complete course link. When it comes to data frames, this is the link which you need to follow. Okay. So let's start with the data frames and the operations on data frames. We will understand what operations and all. So as part of this topic, we will be covering concepts behind data frames. We will define problem statement, and we will see how to implement data frames. Okay. What is data frames? Let me zoom in a little bit here. It is nothing but collection of data organized into named columns. So as of now, what we are doing, we have data, and to process the data, we are actually converting into RDD, and then we have actually splitting and then create them as tuples, and then we are performing RDD operations on them. Okay, RDD operations are join, reduce by key, aggregate by key. All these are nothing but aggregate operations. But there is a better language for most of these data processing, especially when the data is structured, and that is called as SQL. SQL is far more easier to learn while doing any transformations on structured data. SQL is capable of doing almost all transformations on top of structured data, and the structure is defined by creating table around the data, right? But sometimes we might have data, but we might not have predefined structure on that. Okay, but as developers, we are all familiar with SQL, and SQL is a lot more easier compared to writing Java to join the data set, or even Spark. With Spark also, even though it is a lot more easier than Java, still you have to process data in such a way that they can be joined together, and then you have to identify the key if you want to apply any aggregations based on a key. You have to do some data processing, right? Even when it comes to applying the RDD operations. If there is a way to create the structure on it data on the fly, and if we can issue SQL on top of it, or some other user-friendly or developer-friendly framework on top of that data by creating structure on the fly, then you can use any user-friendly or developer-friendly framework to process the data. Example is SQL. You can, if you create some temporary tables on top of the data on the fly, you can actually issue select queries on top of them, and that's the concept of data frame. You don't need to have a predefined table. When you get the data, if there is a structure, and if you have the metadata to identify the structure, you can create, you can assign the structure to the data on the fly. You can register the temp table, and you can actually run queries against it. And this is not new in programming languages. It is there with Python, it is there with R, and they have included as part of Spark also. So data frame is nothing but a defining structure on the fly on the structured data. In Spark, the collection is typically distributed in the form of RDD, a layer between data and programming language API, which can be used to process data. So data frame is nothing but a layer between the data and the programming language API, which can be used to process the data. In this case, when it comes to using data frames, there could be multiple frameworks to process the data. And irrespective of the framework, internally it uses data frame, and there are APIs which will be used internally, and those APIs will be used to execute. So the execution will be uniform across all programming languages when you are trying to use data frames. It is similar to a table in a relational table. Yeah. We can be created from structured data from files. We can also issue high queries on our tables, queries from external tables using JDBC. So all this can be done to convert data into a data frame, and you can apply the operations on it either by using SQL, and there is also something called data frame native operations. So you can use either of them to process the data later. Okay, so data frame API is available for Scala, Python, Java, and R when it comes to Spark. So these are some of the data frame operations: print schema, show, select group, add, sort, and many more. And these are the packages which you need to import. Okay, so we'll start with this. So here I'm logging into the cluster. I'm already in the cluster. Okay, it is hang. So I'm logging in again. Okay. There will be some exercises on data frames. Okay, so you will understand what data frame is all about. So now I am launching Spark Shell, master yarn client. You can try data frames even on your local machine as long as you have the data. Okay, so now let me see. Okay, so actually when we launch Spark Shell, there will be two objects that will be created, context objects. One is SC, which is nothing but Spark context, and the other one is SQL context. Okay, and if you see this SQL context is of type Hive context. So if you want to run Hive queries, and the context has to be pointing to Hive context. But before getting to before running Hive queries under data frames, we will first see typical data frames native operations, and for that the SQL context or whatever object we want to create should be pointing to native SQL context. So we have to create an object. Here I am saying just SQLC, okay, equal to, I can say this one, and also we can first do import org.apache.spark.sql.sql context, and then you can say val SQLC equal to SQL context. Both are same. In this case, I have given fully qualified path. Here I have imported SQL context and assigned and created SQLC SQL context object. So in this case, we are not specifying new. If you see here, okay, we are just saying SQL context. If it will work, if there is a object associated with it, which is nothing but companion class, and there is something called apply method, and if it is there, then we don't need to say new SQL context. Otherwise, we have to say new SQL context. For safety purpose, we will just use new here, new SQL context. So okay, we cannot do that. Okay, then we have to give like this only. Okay, and then here you need to recollect the concept of a case class. Okay, and this is, again, we are actually talking about core Scala stuff. Okay, so we have class, we have object, and we have a case class. So first let us try to recollect what is this case class means. Okay. If I just create regular class, I can do this. If I just create regular class like this, and if I say Java P and then -p and orders, which is nothing but class name, and hit enter. Okay, in this case, Java home is not there and it is not working. Let me do this. Let me create use my local machine. Okay, so here SBT. Okay, now I'm creating case class for class here and hit enter. Now if I say Java P -p orders. Okay, what it have? It just have regular class, and then it have a constructor. So this is how Java class will look like, and the constructor takes 4 parameters. So these are all constructor arguments. Okay, and then we can create orders object, and we can do whatever we want. Okay, and you need to remember that Scala does not have static functions. Okay, so as they does not have static functions, if you have to invoke main function, etc., they provide a feature called object. Okay, so you can create an object and you can have main function in that, and you can invoke main function directly from it. So if you are using IntelliJ, you will create an object with main function, and when you run it, it will actually execute the main function. Okay, so there is a special type of class in Scala, which is case class, and there is a concept called companion object. So what is a companion object? The companion object is nothing but same as your class name. Okay, and that's the only requirement. The object name. So when I say object orders, hit enter. Okay, if the object name and class name are same, and if they are part of same source code file, which is .scala file, then they both are treated as companion object. Here, as we have created separately, it is not taking it as companion object. So what you have to do is you have to use print here or paste. You can use paste, and then you can copy this one. I think I already have in the buffer. So the class is created, and then I'm also saying object orders, and then Control D to finish. And you can see it has created a class called orders, and it has created an object called orders. As long as the class name and the object name are same, they are treated as companion to each other. So it's like husband and wife relationship, and object can access some of the methods in class which are typically private to others, and class can access some of the methods in object. Okay, so on top of these, so Scala have some special methods as part of classes and objects. One of them is require, and another one is apply. Okay, first let us see what is require and what is apply. So here I am creating a class called time. Okay, and I want to have 3 constructor arguments: hours, which is nothing but integer; minutes, which is also integer; and seconds, which is nothing but integer. And then as part of the class, I want to do some validations, and require is one special method. You will see the functionality after I do this. And here, it's similar to assert, but require needs to, the first argument needs to be the valid condition. So in this case, let us say hours needs to be between 1 and 12 or 0 and 24. Okay, so what I have to do, hours greater than or equal to 0 and hours less than 24, and also the minutes greater than or equal to 0 and minutes less than 60 and seconds greater than or equal to 0 and minutes less than 60. Okay, and then if anything beyond this, you if you want to print some message and raise the exception, you can say invalid time and close it. And now the so Ravindra is saying something. It's less than 60 seconds, less than 60. Yeah, I have less than 60 only. I have less than 60 here. Okay, okay. I got it. I got it. I'm sorry. I, I, I got it. Okay, so let me use the IntelliJ. That will be better. I can easily fix these things. Okay, new Scala class, time. Let me name it as time1. Okay, so let me copy this one. Okay, here. Okay, so now let me create object. To make it companion, you need to have object with the same name, and you can have we can have def main args and I just want to create val p equal to new time1, and I want to say 10, 15 and 61 per seconds. Okay, now I want to just print t, and let me override the toString function. Okay, so the way you override is by saying override def toString. Here I want to print hours. Sorry, I just want to print like this. Hours, minutes, and seconds. Okay, so we are trying to missing type annotation. Okay, here I know what is the problem. String. Yeah, I will add that, and also there is a issue with this. Okay, so now I can run this. So now you see it is throwing a invalid type because we have passed seconds as 60. Instead, let's say 15 here, and then save it, and then runtime. Okay, so this is the significance of require. And then there is one more method called apply. Okay, and typically apply will be there as part of the object. You can do it in the class also. Let me create apply method in class as well as apply method in object and see how it can be used. And it is very important to understand this apply method. Okay. So here, let us say apply method. I think it will not return anything, and I want to just let us say I want to pass all three parameters. So there is no hard and fast rule that apply has to have only three three parameters. You can have as many as you want. Okay. So here I am just printing this one as part of the apply method. Okay, it is saying reassignment to where? Where am I doing reassignment? Okay, I think I have to give different name here. H and S. Okay, I know here why it is complaining. Let me see. Yeah, now it looks good. Now, now we have created a time one object and assigned it to variable called t. Okay, so if I want, I can also say on that object, I can actually either call apply and then pass the values and run it. So here I am running the program. So it will print two things. Here we should use println rather than print. Okay, now if I run, you see this one is from apply method, and then this one is actually the println here. Okay, when it comes to apply, it is also a special method. You don't need to pass. You don't need to type dot apply. So whether you can say t dot apply or you can just say t of like this, and then it will actually invoke the apply method internally. So we will also print here saying that println inside apply. Okay, so if the apply is part of the class, and if you want to invoke the apply method, you have to first create the object, and then you have to just say object and then give the brackets, and you can pass the parameters which will be accepted by the apply method. Now if I have the apply method here, def apply, okay, and I am taking hours, int, minutes, int and seconds int. Okay, and here okay, here I will say object apply. When it comes to object, we cannot create we cannot use new on it. Okay, but we can invoke all the functions in the object by saying the object name, which is nothing but this one, dot whatever function name we want. So here, if I want to apply, if you want to invoke the apply method of the object rather than the class, I can say time1 dot apply and then pass the parameters 10, 15, 20 and save it and then run. Okay, you can see that it is actually in the object apply and then it actually printed hours, minutes and seconds. You can remove this apply and here if you run, again it will invoke the apply method. So apply is another special method where you don't need to type apply. Okay, and when you have companion object like this, when the class name and object name are same, they are called as companion companion to each other, and they have access to some private information of counterparts, just like husband and wife. Okay, typically wives know husband's email password, but husbands don't know. I think similar is the case with whatever is available in the class. I think object can access those things, but whatever is available in object, I think class cannot. I'm not 100% sure on that, but it works similar manner. Okay, but the main thing what you need to understand is this one. So when you have case class, when you create a case class, you can actually invoke the apply method of the object like this. And what will happen is, as part of the apply method, typically the logic will be like this. It will, I think apply method will return at least, yeah, I think apply method will return the companion class type. And what you need to do is, here you just have to say new time1 10 15 25, and then when we actually remove this, let's remove this. Okay, what I'm trying to do it here, I am invoking the apply method of object by saying time1 of whatever it is, and then the apply method will be invoked, and in that I am just creating the object of the class. Okay, and then if I run this, okay, it is not printing anything because I'm not printing here anything. So yeah, this is how it will look like. Val t equal to, and then print p. And let's remove these things. Okay, we can also, we don't need to have the parameters. In this case, I am actually creating the object with hard-coded values. Hence, we can also say like this. So when I just say val t equal to time1, it will invoke the time1 dot apply method, and as part of the apply method, we are actually creating time1 class object, and we are returning that. So t will be of type time1 class, not of type object. Okay, and then we are doing print of t, and as part of toString function which is overridden, we are just printing hours, minutes, and seconds delimited by colon. Now, if I run this one, okay, here there is some issue. It is actually printing. Okay, I think I have to override here also. Let me try overriding. ToString here. No, that will not work. Let me see the data type of this. Ideally, it should give the, let me see. So something is missing here. Let me, hours. Okay, we are saying apply. In that I am creating the time one object. And I'm overriding the string. Okay, and the reason why I'm not able to access this is, here these are all constructor arguments, so I will not be able to access that. But I thought I will be able to print this one. I thought this T is of type class, but it is not the case. Anyway, I will figure it out later. But the main thing which you need to understand is when we say apply method, we can actually return the object like this, and we can we can invoke the constructor of the class like this, and then we can this will be assigned with that. For some reason, I am not able to access this. Okay, now let me just remove this. Okay, now what I'm doing, I'm going to the command prompt. I'm coming out of the Scala console and logging in again, launching console again. Okay. Now if I say Java P and -P and then time one and hit enter. So here we are we have a class and we have object, right? So when I define it as class, we are only seeing hours, minutes, and seconds. Okay, as the variables and then few methods. Rather than creating class like this and then object like this, we can also say, we can delete this entire stuff. Let me create a new one. Okay, new Scala class and time 2. Okay, so here instead of actually while creating itself, I think it will show an option. You can say case class and you can give the arguments, and the arguments are hours, int, minutes, int, and seconds, int. Okay, and let's save it. And now if I exit or quit from here and then launch console again, and now if I say Java P -P and time 2. Okay, now you can see it has 3 variables. So this is how Java corresponding Java class will look like. Okay, there is hours, there is minutes, and there is seconds variables in that. And then so these are not variables, these are actually get methods. So get methods are named after the variables here. On top of that, there is a copy command, so which will override the object copy or something. I don't know. And in the class hierarchy, which one will have copy method? But this will have the overridden functionality of it. And on top of it, it also have productarity, product element, which will give some information about the elements of the case class. And then it also have equals, hash code, can equal, etc. On top of it, when we define case class, there will be additional Java type class, which will means Java additional class which will be created, and it will be named under the class name and then dollar. And if you hit enter, you will get additional information. There is a apply method in this. So when we say case class, it will not only create a class, it will also create a companion object to it, and the companion object will have apply method, and the functionality will be like this, the way we have seen in the time one. Okay, so all these things will be automatically available to you. There will be object with apply method, and also as part of class, you will not only have if it is, so by default when we define case class like this, okay, we can also do it from here, case class time 3, and by default when we define the arguments, it will be of type val. You don't need to specify as val. Okay, it will be automatically val. Okay, so here it will be like this, val h int, val m int, and val s int. If you want to, so if you do java p hyphen p time 3 and hit enter, you see the private final variables in time with names hm and s, and then there are getters. Because they are immutable variables, we are seeing only getters. Instead of val, if I say var, now I'm creating one more time 4, and then I'm saying it as var. And hit enter. Now if I say java p time 4, on top of getters, so this is getter for h hours, this is getter for minutes, and this is getter for seconds. And for setters, these are the methods. Because they are mutable variables now, they are not constructor arguments. With a regular class, if you say like this, they are typically constructor arguments, and then you have to define class variables as part of your class, or object variables as part of your class. Whereas in case of case class, whatever parameters you are passing, they are not constructor arguments. They are class level or object level variables. So that's why you can see private h, m, and s here. And then there are setters and getters, and then few more additional methods. And then on top of it, if you say java p hyphen p and time 4 dollar, you will also see corresponding object for it. Okay, now if I want to create an object for time 4, what I have to do is I just have to say val t equal to time 4, and we just have to pass hours, minutes, and seconds, and hit enter. Now the object is created. The t is of type time 4. Okay, and if you want to override any methods in that, in the same case class, you can do it here. So let's try overriding toString function. Okay, print t plus sorry, h plus m plus s. Okay. Okay, I have to go. Sorry, I know what the problem is. I just have to say this. Now it is recreated. The case class is recreated, and now if I try to create the object like this, you can see the time is printed in the expected format. So the toString function is overridden. There is default functionality for all those methods that are available. Now, for example, if I say Java P hyphen P time 4, we have all these methods, right? So now let us understand what is product arity. So here I can say T dot product arity. Sorry, it's val T okay, int does not take any parameters. I need to see the documentation. So case class product arity Scala. Let me see the example. I think I just have to say time 4 dot. Yeah, this is how I should use. No, not a member of object time 4. Okay, so val t equal to t1 equal to t dot product arity. It does not take parameters. Okay, I know. I just have to say this. Yeah. So product arity is nothing but number of elements. Okay, so there are 3 elements, hence it has given 3. Okay, if I say t dot product element of 1, it will give the first element, which is nothing but means it starts with 0, so it will give the second element actually, which is nothing but 5. Okay, so that is the purpose of product arity, product element, and similarly the purpose with product prefix and product iterator is probably to iterate through all the elements of the case class. Okay, all these functions are provided to you with functionality, and you can use as part of your programs. So here I will give some time for you to actually explore case classes, because we will be using case classes quite a bit as part of our data frames, and you should have a good handle over it. Even if you don't understand traits and those things, that is fine, but you should be familiar with case classes before we proceed further on the data frame. So we just recollected the concept of case classes from the Scala perspective to explore further on data frames. So I will give 5 minutes time, 5 or 10 minutes time, and you can try creating case classes and understand what is going on behind the scenes. Case class is nothing but there will be a class with certain predefined functions or methods And also there will be a companion object with a corresponding apply method. And the way you invoke case classes are like this. Means the way you create objects using case classes are like this. You will not use new. You will just use the companion object name of the case class and give the all the parameters, values to all the parameters which are given at the time of creating the case class. Okay, any question here about case classes? Also, I will give some time. If you have Scala on your machine, you can just use plain Scala to explore these case classes a little bit. So here the T dot productarity was failing because this brackets should not be given as it is not taking any parameters. And also here, if you see, this is nothing but getter and this is nothing but setter. So if you are from Java background and if you have used Java beans, you will see get and set prefixed to the parameter name, and you will be using those things as part of beans. Yes, Himanshu, regular class does not have companion object by default. If you want to get the behavior of case class using regular classes, there are several things which you need to keep in mind. By default, the arguments of regular class are constructor arguments. They are not variables in the class. Okay. So first you have to define it as val or var as part of the class specification when it comes to arguments. So here you have to specify. So the difference will start here. It is mandatory to specify val or var if you want to create a case class type of behavior using regular classes and objects. It starts with that, and then you have to provide functionality for productarity, product element. You have to have getters, setters, all those things to make class and object similar to case class. It's not very straightforward. It will take enormous amount of time. I think SQL context is normal class, sorry, case class. There should be a way you can actually go to the Scala docs, Spark docs, SQL context, and you can see it here. Okay, and let us see if they have productarity and all those things. I think it's regular class. It's not case class because there is no function such as productarity and all those things as part of SQL context. So we will not be using SQL context. SQL context will be just to set the context. The main place where we'll be using case classes are to define the structure on our data. That is correct, Himanshu. Again, guys, please raise question by changing send to everyone. That way everyone will have context when I'm explaining. Don't just type privately. So the question from Himanshu is, if you want to have regular class companion object, we have to create it as we have done for the time class today. So companion object is different and case class is different. Okay, when you just have class and object, automatically they will become companions. Okay, with the same name. If you want to get all the methods, the handy way of getting all the methods provided by getting all the methods such as productarity, product element, product iterator, companion object is by saying it as case class. So if you want to get functionality of case class using regular class and objects, it is a very long process. It is very tedious process. Okay, so if you want the behavior of case class, you have to use case class only, which will get you a normal class and a companion object with getters, setters, and few other methods. Is it clear, Himanshu, or do you still have any doubt? Okay, so before we wrap up, let me just show you how to use the case class. Okay, and then we'll continue on data frames tomorrow. Okay, so now as part of our lab, okay, here I have created instead of class, let me create case class. So I'm copying this. Okay, case class is created, and which will give us all the companion object and also the methods. And now, if I want to assign the values while passing into this case class, okay, first I'm reading orders data. So I'm now using Scala Spark APIs. So sc.text file will read the data, and I have data under slash public slash retail underscore db slash orders. Okay. Now I want to create a RDD with using this case class, and then I want to register as data frame. Data frames and all we will do it tomorrow. So now if I want to process our data, which is in this RDD, orders is nothing but RDD, and the way data will look like is this orders.first. I'm running orders.first to get only first record, and you can see there are 4 columns, and all the 4 columns are separated by comma, and each record is of type string. And now I want to create object of our case class type and then RDD of those objects. So what should I do? Which Spark API I should use on top of this orders data? Any guesses here? So we need to use map. So orders.map. Okay. So now we will create a variable called rect, and we will provide anonymous function to that as part of applying this map. While applying this map, we will try to provide functionality using anonymous function. So what we need to do now? We have to assign elements of the string into our case class and create objects of type orders, and then create RDD out of it. Okay, and maps output is nothing but RDD, but each element has to be transformed. So we need to provide the transformation logic here. So first what I will do is I will create a new variable called O, and then I will say rec.split, and then comma. So what does this give? Now what is the type of O after saying rec.split? Any guesses here? Yes, Virendra, yes, you are spot on. It's of array of string. Okay, so we can read this array by using the subscript. If you say O of 0, it will give this one. O of 1 will give this one. O of 2 will give this one. O of 3 will give this one. Okay. Now, how can I create the object? Using the apply method of companion. What is the name of our class? It's orders with O capital. Orders. Okay. Either you can say apply here, or you can directly open the bracket, and then you can say O of 0. Okay. So do I need to do anything here on top of O of 0 while creating the while creating the object casting. That's correct. So here we have to do toInt. It's very, very important. That's why I'm asking, especially the keys. You have to typecast as early as possible so that the performance is as optimal as possible. And O of 1 is already string, so we don't need to typecast. And O of 2 is again integer, so we have to typecast, and O of 3. And also when we create the case class, we have to mention the appropriate data types here. Okay, and now I close it, and I close the curly bracket for map function, and then this circular bracket for the map function, and hit enter. Now orders map is nothing but a RDD, and each element is of type orders. Okay, and if you want to print, you can say orders map dot collect for each println and hit enter. Okay, can you guys guess why it is printing like this? So if we, no, toString is overridden. No, it is not default toString. It is actually overridden. I think you will find it here. See here. There is a toString method, and the default behavior of case classes toString method is to give the class name or case class name, and then elements separated by comma. That's why toString actually printing the records. If that is not there, then it will print the byte address of the object. Okay, so is it clear when it comes to case classes? If you have any questions, you can ask tomorrow. Make sure you understand this, because we'll be using case classes when it comes to data frames. You can actually go here, go to my material, and refer the example. Okay, after this we have to apply 2DF to convert it to data frames, and then we will see the data frame operations tomorrow. Okay, Friday there will not be a class, so just keep in mind because of Shivratri, there will not be class on Friday. And also next week, Tuesday and Wednesday, there will not be class. I am going to Tirupati and to my cousin marriage, and I will not be able to take classes on next Tuesday and Wednesday. Okay, so tomorrow there is no class. So any questions here before we? Not tomorrow. Day after tomorrow, on Friday. Today is still Wednesday. I thought today is Thursday. So day after tomorrow will not be, there will not be class, and also next Tuesday and Wednesday there will not be any class. Okay. Okay, then thank you very much. I will stop sharing the screen, and I will mute for a few minutes so that I can actually set up the YouTube live session for the second part of the workshop, and then we'll take it from there. So those who are on YouTube live, thank you for joining the session. As I have mentioned, I just earlier also, I just started a new batch last week, and we wrapped up Scala, and we will be getting into Spark from today. And the timings are 2:30 p.m. to 4:30 p.m. India time. And you are free to join these YouTube live sessions and start learning from there. And if you want to practice, you can sign up for the labs.itversity.com, and I will not be able to take questions on live chat because these sessions are for corporate clients, and I'm just streaming so that people, for two reasons: one, backup for those guys, and also people who don't who want to learn at their own pace can learn for free and be up to date with the technologies. So that's why I'm streaming online as well. So you can follow these videos. We'll be wrapping up Spark sessions in next 3-4 sessions. But the afternoon one just started. If you want to start from scratch, probably that will be the good place to start. And there's a playlist for that. So let me give the link for the playlist. and then I'll wrap up. And also to practice, if you need environment, we have big data labs. You can go to labs.itversity.com and start practicing from there. So this is the link. Okay, so I'm wrapping up. I'm stopping this, and I will be launching another session, which will be on Hive. The second part, we are in the middle of Hive, and if you are interested, you can join that session also. Thank you. Bye.